Good morning, everyone. My name is Boyu. I come from New York University of Dhabi, and currently I'm working with Professor Borja. And today I'm very glad to present our work, 3D segmentation in construction, agent-based approach using 3D Gaussian Splatting and multi-modal large language models. This is all my for today's presentation. I will briefly introduce the background, technical challenges, followed by methodology, experiment, and limitations. So some brief background. I think everyone sitting here knows that reality capture has been widely utilized in our AEC industry. And here is the standard workflow for the data scanning and post-processing. We do the scanning and export the outside photos and point clouds, and we try to do some semantic understanding, segmentation, and execute modeling. This is also known as scan-to-bin. Although a lot of research has been done in this area, but in practical projects, it still remains manual because there are some technical challenges. The first technical challenge is the generalizability. In the past decade, we have trained a lot of models in different disciplines like indoor scenario, construction scenario, facility management scenario. But when we try to transfer the model from one scenario to another scenario, the model will fail. And the second problem is the interpretability. Like some model may perform poorly in some areas, like shown here, but we cannot explain well why it's the case, and we cannot adjust several parameters to make the correction. And we kind of lost control of the black box inference. And third problem is the rationality. Like previous models may miss some details, like missing connections in MEP and also the physical relationship. So here are some potential, with the recent technical breakthrough, there are some potential solutions to addressing these issues, like multi-large language models. It can, because it's trained on oceans of data, it can have the capability to recognize the scenes from discipline, and it may be a potential solution for the generalizability. And second is the interpretability. Here we have the 3D Gaussian splatting. It allows us to view every details in different angles we want. And the third thing is the rationality. For this, we can create a knowledge graph and establish the connections between the different components. These are good techniques and they are good foundation, but how to leverage them for the complex 3D environment segmentation. That's why we propose our methodology. Yeah, the basic idea behind our methodology is that we can observe that human engineers can easily do the 3D segmentation by through some by controlling their view angles. So in this manual segmentation process, we identified two critical views. The first one is the recognition view. Taking this safety barrier as an example, it's easier for us to recognize this is a safety barrier. But when we try to segment it out, and we may draw a polygon here, but it will include some irrelevant objects like shown here. Another significant critical view is the cropping view. In this view, we can easily crop the targeting object out, but it's not friendly for us to recognize object. So the basic idea behind this is that how we view the built environment really matters. So inspired by the human process, we propose our AI agent for the built environment segmentation. It has three modules. The first one is the action module. It works like the hand of the whole system, which is responsible for the hybrid pre-segmentation, and it will pass the pre-segmented clusters to the second module, which is the observation module. It will work as the eye of the whole system. In this module, we will calculate the best recognition viewpoint and do some rendering. And the rendering will be passed to the third module, that is the analysis module, which serves as a brain of the whole system. It will do the semantic analysis and assign label to the pre-segmented clusters. Yeah. So this is some detailed steps for the first module, action module. We have the raw point clouds, and we do the 3D spatial clustering segmentation, which is very classic. And also we will do the class agnostic segmentation in the 2D orthogonal view, and which is a best crop view for the construction site. And then we try to fuse the segmentation from both 3D segmentation and 2D segmentation, and we finally generate this hybrid pre-segmentation results. And till now, we have divided the whole scenarios into different but meaningful clusters. And for each cluster, we give it a label. Maybe it's too small here. And through some adjacent analysis, we can convert these clusters into the construction scene graph for the analysis. And the next step is the observation module, and we will go through all the list of all the clusters, and we will try to calculate the best recognition viewpoint in a spherical coordinate system, which is defined by 3 parameters. The first one is the radial distance. By controlling this parameter, we can make sure the target object is located on the center of the image and taking the majority of the image. And the second one is the azimuth angle phi. And by controlling this parameter, we can make sure we view the targeting object in the frontal view, but not the oblique view. Yeah. The third one is the elevation angle. By controlling this parameter, we can assure the minimal occlusion in the observation. So based on this is the viewpoint calculation steps, and finally we can calculate the best viewpoint like shown here. And based on this viewpoint, we can generate the 3D Gaussian rendering results like shown here. And at the same time, we can get the 3D point cloud projection in this specific viewpoint. And also, we can get the cluster ID from the scene graph we have been creating. And the next step is the most important step. We will try to overlay this polygon to the 3D Gaussian rendering, like shown here. Yeah, so here we got a high resolution image and also the bounding polygon and also the class ID. And then we will feed this all this information to the large language model. Here, the purpose of this step is that we can let the large language model to focus on the specific area. Here I call it visual attention prompting strategy. Yeah. And then we feed this to the large language model, and we can ask a serious question like, this is a construction site image, and I have mask of the region of interest in red polygon, and please tell me what is the object in this area, and please answer it in a structured format. And then we can also do the object matching and physical relationship analysis. So this one is a very typical answer from the large language model. It can accurately recognize this temporary safety barrier. And also we have done some testing in more complex scenarios like shown here. Our system can not only recognize, oh, this is a boom lift, and this is a work platform for the boom lift, and also this is a view, this is a view, and it can even recognize all the parts belong to the same instance. Right? It will all do like they are same assembly. And also it can recognize the relationship like the supporting relationship between the host and the metal frame. So we have conducted a serious experiment in one public utility building and one hospital. Yeah, so our system can not only output the semantic segmentation results like shown here, but also the detailed semantic scene graph like shown here. Yeah, and quantitatively we compare our method against the state-of-art method like OpenScene, OpenMask 3D, because they are state-of-art zero-shot learning point cloud segmentation method, and they also leverage the semantic information from 2D images to the 3D. And we found in construction scenario, our method outperformed this method with a large margin, and we can achieve more than 85% mean IOU in these two scenarios. Yeah, so here comes the limitation and future work. One limitation of our current method is we lack the closed loop relation analysis. And the second method is the view control is not flexible enough. We just use two critical views to do the analysis. So that's why we introduce our ongoing work. In the ongoing work, we can introduce more skill sets for the operation module, like zooming, rotation, translation, and cropping. And also for the closed loop relationship analysis, we will introduce this plausibility analysis and ambiguity localization module to close loop this method. Yeah, that's all for my presentation, and It's my linking the official website of our construction research group. And if you think the work is interesting, please cite our related articles. Yeah, thank you.